So now that we can figure out with moles how to get the amount of grams of each of our elements, you can figure out things like percent composition of certain compounds and things like that. It's a very simple formula. You basically take the mass in grams of whatever element you're looking at, plus the total mass of the compound. So if we're talking about like H2O, you would do the mass of just oxygen, opposed to the mass of the oxygen and the two hydrogens. And then you multiply it by 100, the same as you do any percent, and you get the percent composition that would be made up of oxygen. Here you can see the example of copper 1 sulfide, where we figure out the percent composition of copper and the percent of sulfur in that compound. So you can see that the two coppers plus the sulfur together is 159.16 grams. Copper, just two of them, is going to be 127.10 grams. And so when you divide that and multiply it by 100, you get that it's 79.8% copper. The rest of it, though, is 20.15% sulfur, done by the same method. And so the one before was done with the formula. This one's done by just giving you the mass of iron and oxygen. Rust, by the way, is what we're making here, iron oxide. But if you have their amounts already, you can just go ahead and divide and multiply by 100 and get the percent composition of each of those. But to be truthfully honest, that's not the most useful thing in the world, because very rarely are you finding a compound where somebody already knows exactly how much of each of the ingredients are. It's usually another way around where you have a lump sum of the compound, such as this one. So this one, you need to figure out how much copper are in a lump sum, 38 grams of this copper 1 sulfide. Well, because of the formula, you know that it's 79.8% copper. So if you know that, if you're not sure how to do this, any percent, if you divide it by 100 and multiply whatever your total is, so in this case the 38 grams, you'll get the percent or the amount of just that item. So notice we take the 38 grams of the copper 1 sulfide, multiply it by the percent of copper that is in decimal form, so 0.79852, and we get that there's 30.3 grams of copper in it. This is probably the most useful way percent composition can be done. For whatever reason, some people just like this method better, where you can always assume that the percent is just out of a 100-gram sample of your total. And so if we know, and this is potassium chromate, if we have 16 grams of potassium chromate, how much potassium is present? We know that 40.3% of potassium chromate is potassium. So this should look somewhat familiar. It's off skew a little bit, but basically this is our railroad tracks again. So you take the 16 grams that you're given of potassium sulfide, you have that there's 40.3 grams of potassium in every 100 grams of potassium chromate. And that basically is the exact same thing we just did, where you multiply it by 0.403, but because you're dividing it by a 100-gram sample of the total, it just looks different. It's the same math whatsoever. It's just not converting that percentage into a decimal. It's keeping it as an amount, saying that this is out of 100 grams of it. It does the same thing. You still divide it by 100. You still move the decimal 2 places over before you multiply it, and you get 6.45 grams of potassium. Just another way to look at it. Hope that makes sense. And the last thing we really need to understand with percent composition is that it's not just an individual element you can do this to. You can do it for an entire compound, such as water. So if we were looking at this is probably a little odd for you, but you'll see this in a lot more chemical equations. This is calcium chloride dihydrate. It's called a dihydrate because it just has 2 water molecules that end up attaching to this one molecule of this, all right? That's why it has a coefficient of 2 there, by the way. And so you have 2 H2Os and 1 CaCl2s, right? So because of that, we can figure out how much of this overall product really, or resultant, is just pure water. And we do that the same way we did it before. We take the mass of just H2O, so 2 hydrogens and 1 oxygen that we got from the periodic table. So, add those together. And then we divide it by how much of all of this, the mass of all of this, and then multiply it by 100, and you get that it's 24.51% water. That's how much water it is. Now, if you noticed, this was H2O, and so you had 2 hydrogen, which are about 1 gram apiece, and oxygen, which is about 16. Well, that's only 18 total. 18 is a lot less than 36, but notice we had 2 of those. So if we're finding water, we have to take into account that we have 2 of these water molecules, and that's why we get that 36.04, because 18 times 2 is 36, and then that's part of the total there and gives us the amount of water that we have. So percent composition, if you can do a percentage, you can do this. The other thing is just realizing that you can do it for pretty much everything, adding up all the parts in grams that you get from our mole conversions, and the fact that the periodic table writes our mass in grams per mole, and so we would consider each element a mole amount, basically. Things like that. It just all works together so we can do these percent compositions.